Dear learner, let us start to try to understand this nomenclature of a steroidal compound. Basically, we know this IUPAC name of a compound which is given by basically there is a word root, then a primary suffix, then secondary suffix, we have secondary prefix, we have a primary prefix, and this all the system is make a IUPAC name of a organic compound. Now here my goal is methane, meth, eth, prop, but, pent. They are the word root for the aliphatic compounds. Now today I will discuss with you regarding the word root which is used in a steroidal molecule. So what we will discuss today is a word root in a steroids. Let us go ahead. With that we can understand a basic nomenclature of steroidal compound. So basic structure, if you will see that, then we have the structure. If we see that we have a benzene. From the benzene we get naphthalene. From naphthalene we get the anthracene, and from that anthracene we have a little bit arrangement and we are getting the phenanthrene. So this is also known as a cyclopentane, and saturated phenanthrene is known as a perhydrophenanthrene. All the hydrogens are added instead of a double bond. So the basic structure of steroid is known as a perhydrophenanthrene derivative. So this D ring, there are four ring: ring A, ring B, ring C, and ring D. So ring D is a cyclopentano, and ring A, B, C are a saturated phenanthrene ring. So what I can say, it is a short form of cyclopentanoporhydrophenanthrene. So this is also known as a CPP, or basically we can say that it is a Gonane derivative. Gonane derivative. To give the number, always we try to give a number in a very systematic way. So we have to remember either a number or we have to recall easily in such a way. So we have A ring, then B ring, then C ring, and then D ring. So we have to start from the top of the A ring and completely rotate to the reach to the B. So that means it is also looking like this. See, it is like this. From the B, we have to move in the C. So it is a C. It is like a C. From the C, we have to form a D, and from that we goes down. So I will give you a number. See, from first we will see A to B. So up to A to B, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is a basically this shape of our name. Then we have to move like a C. Then we have to move like a D, and then we have to come in this direction. So this is one of the way we can easily recall it. So we have to remember meet, eat, pro, but, pant. In such a way we have basically a five word root in case of the steroid. So the G is the alphabet of seventh positions. Suppose I have A, B, C, D, E, F, and G. I calculate 1, 2, 3, 4, 5, 6, and 7. My goal is easily to recall the number of carbon. So 7 carbon not possible. So this is 17. number of carbon at here. We have added extra 10, so we get it. Okay, that can just for recall it. So this is nothing but like this. It is look like 8. So the E has 18 carbon. Then this one, this is like this. So I can say it has a 19 carbon. So here P we can say like this. So I added 2. So I get a 21 carbon. And the first is 17. The last one is a 27. In that way we can easily recall the number of carbon which is present in a given basic ring structure. Suppose a first is guanine. Then E stand for estran. Then A stand for androstan. Then P stand for pregnant. C stand for cholestan. So here it is like methane, ethane, propane, butane, pentane. Likewise that. See if you see that ANE, 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 ANE. So meth, eth, prop, but, pent, hex like that. Gone, est, androst, preg, cholest. So dear student, let us see this how the 17 carbons are there. See, calculate a number of carbon. It is 17 at here. So from this short form GEAP C, GEPC. So G, from that we can go to the estran. So I have given you this remembering that the numbering is given like this. Like this. So the next carbon, or it is at here. If you see, you can see here number of this is 18, and this is known as a estran. Let us move from this estran. We have a next is A. A has a 19. The next carbon will come at here, and that is this one, that is we have added in estran. Now we added here. See, this S3 is not present in estran, but it is present in androstan. So androstan has total number of 19 carbon are present. Let us go from that, that is a pregnant. So now there is no possibility to can add the methyl. So we have to again move to the top positions and we start to add here. That is this one. This is what? This is we have ethyl group. So this is extra. This is already occupied. This is already occupied. This is in 18th position. This is 19 positions. This is 20 positions, and this is a 21 positions. So these are the basic root of the steroidal template, that is guanine. This is what? This is guanine. Then we have estran, then androstan, then pregnant. From the pregnant, we move to the last, that is 17 plus 10, that is a 27. So I can say that it is nothing but it is a cholestan. So cholestan, instead this structure, whatever I have round, it is very important for us. So I draw here this to explain you how to draw the cholestan. Basically, okay, just a little bit it is going to be change. I will again try it here. See here, this is cyclopentano per hydrophenanthrin derivative. Okay, this is estran, this is androstan, this is progestan. Sorry, pregnant. Now from here I have to again form a ring structure of 5 member. So I could get like this. So it is also, if you see it here, if it is not here, but if you look like this is also 5 member. So we have to try to make a 5 member. And the best thing is, this is 18, this is 19, this is 20, this is 21. The extra part is connected at here. It is 22, this is 23, then 25, 26 and 27. So here we could get that 23, this is 21, 22, 23, 24, 25, 26 and 27. Okay, so I always suggest you remember in this format only. So this format is nothing but again make the 5 member, then a look like isopropyl, then it is easy. So dear student, you are able to find out the gonane, Eastern, Endostan, Pregnant, and a cholesterol. If you say here, always this is written here 5 alpha, it is written here 5 alpha, it is written here 5 alpha, it is written here a 5 alpha. Basically, I can say that you can also easily remember that. How many alphabet we have taken here? 1, 2, 3, 4, and 5. So the 5 positions hydrogens is more important, so we can write the very importantly way. The stereochemistry is a wide topic, I am not covered at here right now. Let us go and see the basic ring structure. So hydrocarbons are a cyclopentano per hydrophenanthrene. So I can say this is cyclo, this is pentano per hydrophenanthrene ring, that is A, B and C. So phenanthrene ring is basically made up of ABC, that also we have seen very rightly. Then 5 membered ring, that is D, that is cyclopentane per hydrophenanthrene. The phenanthrene is converted to per hydrophenanthrene and that is a saturated ring and it is ABC. Completely saturated derivative. So there are two positions, beta and alpha. Always we have confusion. Beta either above the plane, beta either below the plane, alpha either above the plane, alpha either below the. So I will suggest you always write in such a way. Alpha is like this and beta is like this. It itself indicates that alpha away from the reader means below the plane, and this is alpha toward the reader, that means toward the reader. So what the thing which is going away from you, very far away, very far away, very far away, our eyes are not able to see properly, so we can get the easy thing like this, dash dash dash, and the things which are comes toward us, toward near to our eyes and near to our object, then we can say we are getting a very thick line. So this is very thick line, very easily we can recall it. And sometimes somewhere if it is written like that, that means confusion. It itself indicate that the round and round, round and round, round and round, that is confusion. Confusion is that stereochemistry is not clear. Stereochemistry is not clear in that case, is it? Let us go ahead. So in the case of it here, if you see that steroidal template, and that is our gonane. The conventional drawing does not shows this 8th position, 9th positions and 14th position. So this is 9th position, this is 8th position, this is 14th position. This line, if you extrapolate, this is going to downward. The downward is nothing but it is alpha. This line is also going to downward. That is nothing but it is alpha. And this line is going to up. So this is nothing but beta. So if in your steroidal compound, the 9th positions, if it is alpha, no need to indicate. If the 14 positions is alpha, there is no need to indicate. The 8th position is beta, no need to indicate. I hope you understand that. From here I moves in this directions. From here I moves in this directions. From here I moves in this. The direction itself should indicate that the in case of 9 and 14 go below the plane, and in the case of 8 it goes above the plane. Is it? So carbon at the fifth positions GEAPC. It is always drawn either it is 5 alpha and 5 beta, because a stereochemistry is a very important and essential part at here. So if we move, always you have to write stereochemistry of the fifth positions, aliphatic side chain at the 17th position. So we have two this number. The one is this one and the one is this is on the top positions. So it is like in the top directions. So it is beta. This is the down positions. So it is downward. So it is most probably, I'm telling you most probably, not always. It is like 5 alpha. Okay. So in that case, you can remember it. So notation 17 beta need not be used. If it is 17 position is beta, there is no need to indicate. It is by itself indicate or itself self-explanatory. Let us go a steroidal nomenclature of the double bond. So there are possibilities where double bond could come, and what interesting scenario we are getting in the double bond. Suppose this is one of the structure. This is another structure, and this is one more structure. In all the structure, if you observe, then the double bond I have inserted, and here the one more thing we have to remember. See the stereochemistry of these positions. There is no need to indicate the stereochemistry of these positions. This 9 is downward, 14 is downward, 8 is upward. So there is no need to indicate. So let us give the number first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Let us take another example of that case. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Let us take a lower one also. In case of that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and this is our 19. Let us see that if I have a double bond like this, so I give a number 1 to this, 2, 3, and 4. Another possibility, somewhere the student can also write that. Somewhere the student can also write in such a way that they are getting a numbering in this way, like 1, 2, 3, 4, and 5. But this numbering is always we can consider appropriate or ideal. This numbering is not indicated. So if here we will say this double bond, it is between 5 and 6. Here double bond is between 8 and 9. Here double bond is between not 8 and 9, but it is 8 and 14. So that is in sequence. That is very happy. This is also in sequence. We are very happy. This is not in the sequence. If it is not in sequence, how to indicate a double bond is very important. If we only write the 8, then it could be like 8 and 9. So let us see. So this is two things we have to understand it here in this structure. If the fifth position carbon has sp2 hybridations, there is no story of alpha and beta. Alpha and beta story come only in case of single bond. So we have alpha glucose and beta glucose, that is a single bond. Second, a delta raised to 5 is also indicated somewhere. Delta raised to 5 is what indicate that the fifth positions has a double bond. If it is, it shows here. So this is very simple name and all are indicating the same thing. This is a new thing for us. And another one is sp2 hybridization. They all are in the same plane. So there is no need to indicate double bond. Sorry, alpha positions. Comment here. This is also very simple. Now here the fifth position is not an double bond. So here we have to indicate alpha positions. Delta we are using to indicate a double bond, a presence of that. And instead of androstan, if it is like that, androstan. So we have removed for systematic nomenclature. We know that we have to remove the ane and we add what, ene. So it is androsten, and as such whatever the we are giving the nomenclature, similarly we have to follow it. Let us go here. This is very important for us. Here we have to more focused on between this. What it indicate? It indicates that the delta positions. Sorry, delta shows the double bond, but double bond start from the 8 and it is between the 14. If a double bond is not in sequence, not in sequence means not between 1 and 2, 2 and 3, 3 and 4, 4 and 5. If it is like that, there is only indicate one number. But in case of steroid, it is possibilities that a double bond can be between a non-sequential number. In that case, we have to indicate this way. So 8, the starting bonding from the 8 and in the numbering, and the highest is comes in the bracket. 5 alpha we have to indicate when if there is no double bond is present. So this is a basically structure to indicate the nomenclature of the steroid. So we have some steroidal hormone. If we say this is due to that, it is estrogen. This is due to androsten, and this is due to pregnant. Okay. Now, if we see that in our GEAPC, except this, these three are giving are very important for us right now. This is first, this is last. So always we have to add a functional group. So this has 2H, this has 2 ketone, and this is in between that. So I can say androsten has OH and a ketone also, like that. This is somewhat easy to recall it. So if we say that from the estrogen we can form the estradiol. So the thing is this OH is extra. Then the second thing is this OH is extra, and this is an aromatic. This three things we have to observe it. I have told you in case of estrogen all are OH. Let us move. This is 17 beta estradiol. There is no need to indicate these 17 beta positions. Then we have next is a pregnant. From the pregnant, we have to make a 2 double bond. So from the pregnant, we form the progesterone. Progesterone has a 2 ketone. One is this, another one is this, and this is a in progesterone. A double bond is there in case of the fifth positions near to fourth and fifth. So this will give the progesterone. Now you get the logic. Androsten has both OH and C double bond O. So I can say that here they have tried to make easily this portion they have taken from the progesterone, and this portions I can say they have taken from the estradiol, and these two positions that will make a compound, and this is known as nothing but a testosterone. So testosterone is very interesting for us because it is very easy. Estradiol is estrogen derivative, progesterone is a pregnant derivative, but if anyone say testosterone is a testis derivative, sometimes people like say that, but it is not a testis derivative. It is produced from the testis, but it is androsten derivative. This is basic molecule is this one. Good. So this is very basic steroidal hormone which can be synthesized in our body. And let us go ahead. Name of the some drug. If we see here, I will not explain a whole IUPAC name, but I will try my best to explain why it is pregnant. If we see that it is pregnant, then there is a so 21 a carbon would be there. So if you see here, I draw the structure, a bracket. This is like a pregnant derivative. So in case of pregnant, a word root is pregnant, and from that we remove this, and instead of that we add ene at the fourth positions. Are you getting my point? So this is a whole IUPAC name we are not discussing right now. Our goal is only to discuss to you and inform to you about which word root is present. The whole IUPAC name story we will try to understand in the next video, that I will cover most of the IUPAC name which is used in field of pharmacy. So this position is very easy to understand. This is alpha positions. Are you getting my position? Are you getting my indication? This is alpha. So let us go ahead. One more the IUPAC name we have. This is a triamcinolone derivative, and here it is also written that it is a pregna. So it is pregnadione. So why it is A? This is also one of the more big story for the IUPAC name that we have to learn it. See, this is a pregna derivative. So in case of pregna derivative, if we see the 16 positions, so if anyone want, then they can give a number 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, then 11, 12, 13, 14, 15, 16, 17, 18, 19, then 20 and 2021. We are very happy. We are very happy. We have, this is a pregnant derivative. So when we are writing the pregnant derivative, so dear student, please understand that this is not a COOH group. This is not a COOH group. So let us see. This is 9 alpha. If you see here, this is alpha positions. 11 beta. If you see that, this is a beta positions. 16 alpha. If you see that, it is dash dash dash. If you see 17 alpha, this is like this one. So in that case, in that way, we are so many IUPAC name of a compound which is covered in and required to understand basic nomenclature of the drug. These are the basic requirement to understand and learn in case of a steroidal compound. If you know that, then and then please go ahead. Stereochemistry of this steroid is also important, but it is not my job today. But later on, if people wish, then I can also include that a stereochemistry of a steroidal compound. Let us continue, enjoy organic chemistry and medicinal chemistry and spectra analysis. You have to get update. For that, you share and like and subscribe this video. Thank you.